Hey, hi guys. So in this video, we are going to discuss this delivery truck loading system concurrency problem. Let's go through the problem first. So consider that we are a logistic company which have a multiple docks, and in each of the dock, truck can go there and stand, and workers will start loading the packages onto the delivery truck. Every truck will have a weight or a volume limit. Packages arrive continuously from the warehouse, so there is a warehouse from where the workers are taking the packages, and they are parallelly attempting to load the packages on the truck basically. So once the truck is full, it is dispatched and the new truck arrive at the same dock. I mean, that's how the process goes on. So this is the problem which we are looking to solve now. What about the concurrency challenges? What if we let's talk about a brute force solution for this. Or like, what are the problems we will face in the brute force solution? What if each worker is independently checking the space in the truck and then loading the packages? There may be a chance that they both may check the space at the same amount of time at the same moment, and they will see, hey, space is left, and they will fill the packages. So in that condition, what will happen is truck will get exceeded with the capacity. Let's say if the capacity was 5 kg, it will become 6 kg or 7 kg. So this is the problem which we have. This is one of the biggest problem which we have is with the naive approach. If we are allowed to do the workers all the work independently, we will face this concurrency problem. Now what can be the solution? Like, the first fix which comes to our mind is like, hey, why not lock it? Whenever they are checking the access of the truck, let's add a lock so that only one person or a one worker can access that particular truck capacity information at one point of time. Yeah, so if we do that, if we add the, let's say if we add the synchronized lock, what will happen whenever the worker will try to load the packages into the dock or the current truck, it will always check whether the truck have a capacity or not, and we will be using a synchronized method here. So only one of the thread or one of the worker can check what is the current capacity of the truck at a particular moment. So if other workers want to check it out, they will have to wait until the first one gets finished. So basically what we are doing at the end is we are serializing the operation. We are not serializing the entire process. The worker will still take the packages from the warehouse, come to the dock. Parallelly, there is no dependence, but at the time of loading, they need that step needs to be sequentialized or basically serialized. Now what we are planning to do is we are going to have one monitor lock, or you can just say we can simply say, hey, one lock per dock. Why not one lock per truck? That we are just going to discuss more in our course. But for now, let's consider we are considering one lock per dock. Let's say a warehouse can have multiple docks where in each of the truck can come and stand there. So we will be considering every one lock per dock. So now what will happen is every operation, any operation which is related to read, write, or updating the truck capacity needs to be done under a lock, needs to be sequentialized or serialized basically. So the whole sequence of checking the current capacity of the truck, loading the package, new packages into the truck, and then leaving it. So this entire flow needs to be sequentialized and it needs to be atomic. Okay, let's say if we found it out that, hey, uh, that the check load, that, hey, it's not working out, so we are not going to do any of the transaction at all. This entire flow will be a single transaction. That is what we really meant in the atomic here. In the code, if you see, we are just having this basic public class. Inside this is like a pojo for the package. This is representing the truck state, and this is the again another pojo for the truck. Now here, if you see in the doc, we have this atomic integer. This contains the truck sequence number, or you can say number plate, whatever you want to call it out. Okay, and this is the current truck information, basically the class which we have defined to the up, and this information shows us the truck capacity, basically current truck capacity. Actually, it can be even taken from this truck also. I think maybe we can refactor this code somewhere. So if you see in this load, we are using this synchronize function. So what will happen? Any thread which is trying, any worker which is trying to access this particular doc class will have to wait if if anyone else is kind of inside this code already. So first it will check whether the truck is active, then it will check whether the packages can be fit into the current truck or not, and then it must fit. And then once it is done, we see that hey, if the capacity have already got full, we kind of dispatch it, and that's how we uh, are doing this entire operation. And I think that is it. Other codes are just simple calculation which we are doing. I don't think so. Is there anything related to the specifically design? Yeah, one more thing which you can say here is how we are simulating the workers. We are using the thread pool here, considering that hey, there are eight workers in the factory or warehouse currently, and you can say these eight workers are trying to load the packages into the trucks or the dock, whatever you want to call it. So this is how we are simulating this truck loading situation. Okay, now at here we are kind of, you can say, having 60 packages, and that we are adding to this incoming, and all these things are getting submitted. So what we are doing is we are saying hey, we are having 60 incoming packages. Okay, this one we are using this worker, this thread pool which we have created, fixed thread pool, and we are submitting these kind of work to there. So what will happen is six packages will be assigned to the first six worker. Next of them will have to wait until unless any of the thread got exit. Let's say any of the one of the thread have completed their work, then it will assign the next package. So that is how we are able to simulate this entire situation in the code this way. Now another problem or limitation of this current solution can be, there may be a chance that the workers count rise. Let's say if you are having too many workers, let's say you are having 50 workers, 60 workers, that may it's more about the resources utilization. The current solution, we are not able to utilize our CPU properly, and as the workers grow, the CPU underutilization will be growing basically. There may be a chance that if you want to prepare a new truck in the parallel, single locks block it. I think this is one of the limitation, but I think this can be kind of, we can add some workaround to the existing code, and this can be still fixed basic. Yeah, this is a big issue. This is what we see. So what can happen is, since we are using the Java intrinsic lock, those are not very fair. What do we mean by that is, a same thread might win the lock again and again, and it may lead to the other threads not getting the chance to get the execution. For example, let's say there were 66 threads as we were having here. Sorry, 8 threads. Now first thread got the chance to get execution. Now next time whenever this happened, another again first thread got the chance to do this execution, and other threads are still waiting for the lock free. So it may cause the starvations for the other workers, and it may cause the load spikes also, because one worker cannot do all the work. He is limited by the its own capacity. So it may lead to the bad situations, as we have mentioned, load spikes. This is again the same thing. One of the like kind of resource utilization, you can say. If the package arrival rate is more than the service rate, what do we mean by that is, if this incoming packages are way more than the workers we have, in that case, there may be a chance that, uh, as it is mentioned, there may be a chance that the work queue may grow too much. This package, sorry, this queue basically, this package may grow too much, and that can create the memory issues into the entire CPU. So all these things we are going to cover in our course. Soon we will all the solutions. This solution will be added into the course also. The advanced version. This one is already there. I'll soon add the advanced version, like whatever limitations we are discussing here.